This is the exact moment AP Physics 1 starts to feel, well, impossible. Torque, angular momentum, rotational inertia. It's a lot of new Greek letters for things you thought you already understood. But here's the secret you aren't learning new physics, you are just learning a new language for the same physics you have been doing all year. In this video, we are going to cram all of Unit 5 into one session, from the bridge equations to the trickiest FIQs on the exam. Do not skip around, physics is a story, and if you miss the middle, the ending won't make sense. I need you to stay with me until the final slide so you can see how these pieces click together. If you have any concept feels like they are spinning out of your control, drop a comment below. I am checking them daily to help you clear up your doubts. Grab your calculators, let's get into it. So basically, these are the topics that we are supposed to cover in rotational mechanics.
Yes, sir.
This is basically Unit 5, which deals with rotational dynamics. So let's talk about it a little and keep the topics in mind. And let me remind of that which topic we have to next. As of student, the only responsibility you have as of now is your academics, to take care of your academics. Apart from this, everything is very much settled. But yeah, if you are able to take care of your academics, you can make everything settle as soon as possible.
Yes, sir.
So it is basically called rotational dynamics. Let us talk about all those things very quickly. So whenever we are talking about dynamics, we already know that dynamics is a branch of physics which deals with application of force, application of force, or we can say precisely it deals with motion due to application of force. Now there are a lot of possibilities. This is what dynamic is. But if we talk about specifically rotational dynamics, so that motion will be taking place about a fixed point. So whenever we are dealing with motion about a fixed point due to some application of force, the whole thing comes under rotational dynamics. So as we generally know that if force acts on an object, it displaces the object. So if force is actually displacing the object, but here what we made the most important condition that everything should take place about a fixed point. So we know that because of application of force, object generally moves as a whole. But if same force is acting on an object which is fixed about a point, so that force becomes torque. So torque is nothing but it is an application of force which acts on a body when object is fixed about a point. So if it is fixed about a point, still it can do some motion. How? By rotating itself. Let us take few examples, and then it will be more clear. So the only thing, or not the only thing, the thing which we deals in daily life is opening and closing of doors. So those opening and closing of doors are possible because of torque. Suppose this is a door and this is the points which are hinge. So what you have observed in general in daily life that the handles of the doors lies on the opposite end. Why they lie always on the opposite end? Why they don't lie in the middle or close to the hinge part?
Oh, because like if you're further away, right, then the force you have to exert will be less.
Yeah, because we actually have to rotate this door in order to open or close it as far as we go from the hinge. as far as we go from the hinges or the axis of rotation. Because of torque acting about that point, force becomes less. So basically, torque is calculated using R cross F. We can also write it as perpendicular component of position or perpendicular component of the particle distance times force acting on it. So sometimes it is also written as Fr cos theta sine theta.
Oh, so this is the cross product.
Yes.
Okay.
And here R should always be. If it is perpendicular, it is fine. If it is not, then we use Fr sine theta.
So I have a question.
Yeah.
If you had like a helicopter, right? The blades are spinning, right? Where would
Yes.
the torque be? Like what where would it be facing? What would
It
its
is
direction be?
upwards.
Okay.
That's why it is able to lift the complete body of the
Oh, so,
helicopter.
so torque isn't so when you spin the blades, torque is working against the helicopter, right? Because it's technically pushing it down, right?
Yeah, you can say that. What you need to understand here is that what is the axis of rotation? First thing that you have to observe in such questions is axis of rotation, or to be precise, the point about which the body is fixed. So this is the axis of rotation,
Oh
and the
yes.
point which is fixed is always lying on the axis of rotation. Apart from this, if you just observe the plane where these wings lie, I can say. So that plane, about this plane, where is the force acting? Or we should say,
It's like on the arm. Like
yeah. So what we need to understand here is that there are not only torque which is acting in the system, there are multiple other forces as well which plays their role while lifting it upward.
oh yeah,
So it
there's
is
like normal force as well, right? From the
there are
air.
so many forces that actually helps this aircraft to get lifted or helicopter to get above the surface. So there are so many forces. We'll talk about, if it is there, we'll talk about this particular thing. As of now, let us just stick to torque. Let us take those examples where only torque is acting. So it will be a little easier to understand what torque is. Next thing we can use or we can assume is an example of seesaw. You must have went to playground, sat on these seesaw. So in order to have that other person sitting beside you to go up, what you used to do? You sometimes used to jump. So how torque is acting on the system? Here, the torque is acting. Suppose when you push it this way, so the force which is capable of rotating it about this fixed point, that force is basically causing anti-clockwise torque. Whereas the force which you are going to experience and due to which the seesaw is going to rotate, it is going to be clockwise torque. So in most of the question, what we are going to deal is a condition which is known as rotational equilibrium. Let's talk about that. So most of the time, in most of the questions, we are dealing this condition that is rotational equilibrium. Just like translational equilibrium we learned in previous units, rotational equilibrium is also the same. But here, the change is in translational equilibrium, it is said to be that the net force acting on a system is zero. If it is so, then object is said to be in translational equilibrium. Similarly, here in rotational equilibrium, it is said if net torque acting on a system is zero, then system is said to be
Equilibrium.
in rotational equilibrium.
Oh, so the sum of torques must equal zero then.
Exactly. You understand things really quickly. Is it because you have already studied these things like to a greater extent, or is it like what? Just like in translational equilibrium, net force about for a given system is zero. So we can say that the forces acting in opposite directions must be equal. So we can say that force in positive direction must be equal to force in negative direction. Similarly, in that case also in translational rotational equilibrium as well, when we keep torque net as zero, so about that point, torque that is clockwise must be equal to torque that is anti-clockwise. What does it mean? It means suppose there is a rod and this rod is fixed about this point. Now what we did is we apply forces from this on at that point as well as at that point. So this force, let me write it as F1 and this force that is F2. So this that force F1 will try to do what? Will try to rotate it anti-clockwise direction. So it will give it
Oh,
anti-clockwise
they will
rotation.
cancel each other out
If
because
the forces is
the
equal,
same.
if
If
the
it's equal.
forces are equal in magnitude, but if they are not, then
Yeah.
the rod will rotate. Whereas this force is going to give it clockwise rotation. So this clockwise rotation is generally taken as positive because it's just like a sign convention. Similarly, anti-clockwise is taken as negative. So keep that in mind. We'll be using that relation as well as this one if you want, but keep that in mind. Clockwise positive, anti-clockwise negative. Let's do a simple problem. If you are able to do that problem, it means you understood the concept. So a question says, let me just draw it. Suppose there is a rod.
Yeah.
This is of capital M mass. There is a hinge point, you can assume. Also, it is given that the length of this rod is also L. And at this point, we kept a small mass M, which is at L by 4 distance. The question is, what should be the normal reaction about that edge so that rod remains in equilibrium? So this is the question. Now the answer which you're going to get is completely in the variable form. It doesn't matter in which form it is. What matters is how we are supposed to have that answer. Think about it and tell me.
Okay, so if you want it to be in equilibrium, then wait, is it possible for me to add like another mass somewhere else, sir?
Yeah, definitely.
Okay,
But
so okay.
that should not come in the result. The result should not have that.
Okay, so we want the rod to be in rotational equilibrium, right? Then what we can say, right, is that first of all, the sum of torques must equal zero. So right now, on the left side, there's some torque which is going anti-clockwise. So in order to like balance that out, so that we are in rotational equilibrium, what we have to do, right, is we have to place like another mass on
See,
the.
we don't need to place anything here because we are not supposed to place that.
Oh, we're
How
not.
we are supposed to solve, how we are supposed to apply that net torque is zero? First thing, like the step one, choose a point. That kind of point from where maximum forces passes.
Oh, we can just choose the point where the mass is, I think, right? Because then the yeah.
Let us draw this diagram once again to represent the forces now. So there was my mass. This is capital M. So if it is capital M, it must be exerting weight from its center of mass, which is supposed to be capital Mg.
Oh, I forgot about that.
Similarly, this will also going to exert the weight in downward direction, which is going to be Mg. In order
Yeah.
to have the normal reaction at this point, zero, or you can say, if in order to have this rod to be in stable equilibrium, we have 3 points. We can choose any one of these points to find out where normal, what is normal is going to be. The distances is obviously given to us. If we are taking it zero over here, think about it. If we're taking it torque, so again, now what point we can choose to find out where the torque, where we can choose torque zero. First of all, you
Um.
have to understand that what point, what force you have to find. So we have to find normal mass, normal weight,
Oh,
normal
we're being asked
reaction.
to find the normal force, sir.
Yeah, normal reaction. So what we can do is we cannot take torque zero at point B, because if we do so, normal will become zero, and this is something we have to find. So I can choose we take,
I think point C would make more sense, right, sir?
yes, torque net about point C zero, because you have to mention the reason, because it is rotational equilibrium. It is given in the question. If it is FRQ, you are supposed to write it like that. Now let us see that how they are going to give this rod rotation. This mg is going to give it anti-clockwise rotation, whereas this n normal is going to give us clockwise rotation. So there are only two forces that are acting in the system about point C. So we can simply put the torque by these two forces equal. The torque clockwise must be equals to torque anti-clockwise. So clockwise torque is going to be normal times force times perpendicular distance. What is perpendicular distance between these two? About point C we are getting it. So it is going to be L by 2. Sorry, L by 4. Right?
Yes, sir.
Because it acts from the center of mass of the given rod. So it is going to be L by 4. Whereas torque anti-clockwise is going to be mg times what?
It would be the distance. It would be L by 2 because we took the point.
Correct. So normal is going to be 2 mg. So 2 mg is going to be the force that is required to bring that rod in equilibrium. This is how you're supposed to put or apply rotational equilibrium. Now, if you have any question related to this particular concept that you are facing difficulty in while solving, share that question. Let's discuss that. Or whatever questions you have faced difficulty in today's test, you can also share those MCQs. Okay.
So, like in scenario number one, right? There's no string on the top. There's only gravity pulling it down.
Okay. All right. So here in the very first case, it is going down
Yes, sir.
because force here acting is mg.
You know,
Now,
so like the there was a question for this, right? And it was asking me to find the acceleration in scenario one, and I thought G was too good to be true, so I did not put anything. I just put sum of forces
mm,
is equal to ma. I was so dumb, sir. I thought like there's no way this is too good to be true. You know, it cannot be G. So I did not put G. I did not put anything. I just put
see,
sum of forces equal to ma.
uh, that was an MCQ.
No FRQ, sir.
Yeah, just try to understand now what I'm saying is. What I have observed in most of the FRQs, they keep it very simple. Like how they're going to ask you, they just take a concept, they try to ask you a little deep from that concept. Similarly, on the same side, some easy questions as well. So if there are four parts of the same question, then one part
Yeah,
can you can assume that it is going to be very tough, but other
that was the
three
first
are
part.
going to be very easy. All you need to be confident and trust your concepts, whatever you have learned, and try answering all the questions based upon that only.
Okay,
In
so
some questions you might feel difficult, but in most of the questions, like in 80% of the questions, you'll feel that yeah, I know that. So four is not a big deal. Four is quite easy. All you
yeah,
need to stick to the basics. But
yes.
yes, so yeah, so first part was done. Now what about second one?
So the first part was to draw the force diagram, right? But in scenario two, what I drew, right, I think it was correct. The in scenario two, what I drew was force of gravity pulling it down, as well as the force of friction between the string and the ball and the string ball itself, which gives you the torque. So
Force of
like
friction, drag
uh,
force.
so basically the way it works, right, is that the string, the way you drew it, right, is not, it's not coming from the middle, it's coming from the side of the thing, the side, like, no, like from the, yes, yes, like it's coming from the right side of the circle, like it's not coming from the top, sir, it's coming from like
Okay.
it
Yeah,
wraps
I,
around.
I, I I
Yeah,
got that.
yeah. No, not like this, sir. It's just, it's a straight line, but the line starts from the right side of the circle, the extreme end of the circle.
So basically, you are saying that when it is oscillating.
No, there's no oscillating, sir. There's no. You're dropping it straight down. You're dropping it straight down. It's like a yo-yo, sir. You know when you drop the yo-yo, the string comes from the side of the yo-yo,
Okay.
right? And that's what causes it to spin.
So it
From
is spinning as well as.
It's going down in scenario two.
Okay.
Yeah.
I thought that you're saying that while it is going down, it is also showing some sort of oscillation sort of thing.
No. There's no pendulum type of thing, sir. There's no pendulum.
Okay, makes
Yeah. There's
sense.
there's no simple harmonic motion. The okay. So basically, the the side of the string, yeah, like that. It's tangent to it. Yeah. Basically, what I drew, right, is that the force of friction between that and the force of friction is first of all facing upwards. Yeah, like between, yes. So this is what provides the torque. So now they asked me to find, I think the first part was just to find the linear acceleration, right? And that was just g. And I was very stupid because I did not put, I
See,
yeah,
linear acceleration is going to be g in this first
yeah,
scenario, but in second
yeah.
scenario, a is not going to be g.
Yes.
It is
In the second scenario, then they asked us to find the rotational acceleration.
that is alpha.
Yes, to find alpha. So I did
So
not know how
torque
to
is
approach
equals
that.
to I alpha. That is another relation that we use for torque. I
Yeah,
also gave you the derivation of this particular relation.
yeah.
Torque is also called F net times R perpendicular. I alpha, not R.
Oh, by the way, sir, this the string, I'll give you the constants. The mass of the string is m, and it's known to be constant throughout the its descent. So it has mass m, basically.
No, you are supposed to take F net as MA here.
No, I'm just
So,
telling you the mass, sir. I'm just telling you the mass.
okay.
Like they gave it, they
Ma-
said the mass is m. Mass is m,
Yeah,
basically.
in generally they won't give you variable mass situation because in such cases, if you
So
think it
then,
more
yeah,
practically,
the
the
mass is
variable
decreasing.
mass, yeah, the mass is variable because as it goes down, the mass of the whole, you can say this disk system keeps on decreasing because some part of thread is leaving it. Whereas when it comes up, that mass is being added to the system while rotation. So it
Yes.
also affects the speed of rotation. So, but in the questions which we are going to deal with,
The only thing that they're giving us is that mass is constant, so there is no change in mass. So that mass thing will not going to affect the rotation. That is what we can assume. So by using this, you can find out F net over R perpendicular times I. I is what? Moment of inertia. How we are supposed to find out moment of inertia? If you just look at this structure is nothing more than a disk. The mass of disk, or you can say the mass of this ball is given as m. Oh no, it has given that it is a this yarn ball,
It's like
a
half
string
mr
ball.
squared, no? Half mr squared.
No, no. First of all, tell me, is it given that the word did they use string ball in the question?
I forgot. Let's just assume it's like a sphere, which
Okay,
would
so
be 4/3.
there are two possibilities. If we take it disk, then it is going to be half mr square.
I
If we're
think
taking it
logically, sir,
sphere,
it would be a sphere, sir, logically, because
yeah,
they said
logically it
ball.
should
They
be
said they
sphere.
said ball.
So for sphere, what it is?
4/3 mr squared, I think.
2
2
by
over
5 mr square for solid sphere because it is going to be solid. You can
Yeah.
take it as, you cannot take it as hollow sphere. So if we substitute it here, we'll have different answer. Now let's talk about F net. What F net is going to be? In
The
order
f-
to have F net here, you can simply write
oh, that'll be
mg
forced
minus F. Now what is F?
friction.
Generally, frictional force is supposed to be acting along the thread, and that friction force cannot be calculated using coefficient of friction times normal reaction. We cannot calculate friction using this. It is something we simply say that again you can't use this as well. Let me tell you. So that's why I was saying that there are few things that sometimes you don't remember and they plays their role in the question. Let me tell you why. If you're going to find out F net, so F net is basically mg minus this frictional force which is F. Now what this F can be? First of all, it cannot be mu times n because that friction will only act when surface has some contact. But here we won't say that thread and this has contact in that sense because object is not sliding over the thread. It is moving along with the thread. That is one case. Again, so we cannot apply this. Now what we can apply? If we take it as air friction, or we call it air resistance.
They said air resistance was negligible, sir.
Air resistance was negligible, so it is going to be zero. So the only force which is responsible for that object to go down is mg. So here F net will be taken as mg only.
Oh my god, so I got it wrong then.
2 by 5
Oh
mr
my god.
square times r perpendicular, which is radius of this ball,
Oh,
which is
I
also
got
going to
it
be
wrong.
r.
I got it wrong. I
It
said
depends
four.
upon the question as well, like what you have written, what is given in the question. Because these things are very much clear in the question, like what shape you have to choose, how we're supposed to write it. So it is going to
Oh
be
my god, I thought MG is doing the translation and the friction between the. Oh,
F. So alpha is going to be 5g over 2r cube.
I should not have asked you this question because now I know I got it wrong. Oh my god.
No issues. It doesn't
No, no,
matter a lot.
my marks got taken off now, sir.
How many marks were supposed to be?
Well, I got the okay. Look, I could not do the
See,
find the linear acceleration.
such questions has we can say stepwise marking. So for writing this, for reaching till here, you will get
I
half of
said
the
sum of
marks.
torques is equal to 0, but that's wrong.
Sum of torque was equals to zero. But if the sum of torque is equals to zero, then object is not moving. Here the system is moving.
No, but I thought, sir, like it could be since the friction is opposing it, F the friction force and mg could be the same. That's why it was my based on that assumption.
See, in order to pull it upward, you have to apply some external force.
Yeah.
And in that case, this friction is the force which supports the motion. If
Yeah.
there is no friction, it won't be able to come up.
Okay. So I got okay. It's fine, sir. It's fine. It was a mock. Uh, it's not
No
good, but
worries,
it's
you'll have a lot of chances. Don't worry about it. So, all right, no issue. Just keep these things in mind. You have a lot of idea about all these things. Whenever you are solving questions, just try to solve them try to solve as many problems as possible.
oh
See, that is what you have to practice. That is what, like, you have to take a target. Like in next 1 hour, I'm going to solve 30 questions, let's say. So if you take that targets and try to practice those things at home, then only you'll be do with more confident in the exam. Otherwise, you won't be able to sometimes attempt the total maximum number of questions. That can also be possible.
yes, sir.
All right, tell me something else.
Uh,
See, these classes as of now, I suppose that it is should be for clearing your doubts, as many doubts you can clear. Because if
it's,
we cover unit, you have almost idea about all the unit. The application part is there. If you tell me that these are the questions that I'm actually suffering, or you can say I'm not able to do them, we can discuss the concept through those questions only.
yes, sir.
And that will help you more because your doubt will also be clear as well as you will get a quick uh, summary of the concept. That is
Yes,
going to help more, I guess. Because question is something that you have to work upon. You have an idea about theory, but sometimes you're not able to understand or think the way question wants you to think. So that's what makes it different.
yeah. Uh, there was there's also another question I'm not remembering on the top of my head, but I think I'll get the FRQ paper tomorrow, sir. Most likely, not tomorrow. Friday. Friday. I'll get it on Friday, sir.
Okay.
Yeah, yeah. And then I think we do have one more optional mock test which I will take because I want to have a good impression on my teacher so he can give me a good grade, sir. Otherwise, I might be screwed. But
What grade do you think that you'll be screwed?
if I get a two in the class, sir, I'm screwed. I'm not like
No, you
this.
won't
Like
get
this is
two.
this is the no. He said my predicted grade right now because of the
Hmm.
rotational stuff. Right when he said your predicted grade right now is a two. If class ended today, like the whole
Hmm.
school ended today, you would get a two, which is and he told everybody's predicted. So, but he said it's fine because you can change it in 6 weeks. So I have to do well in order to bring it up.
And why your grade as of now is so low?
It was mainly because, sir, it was because of rotational, and I was averaging threes on most of my tests, sir.
How can you say that because
Yeah.
of rotation? Rotation is just a one chapter. It is
Well, the other
hardly
chapters,
15%.
rotation was 25%, sir, and the other chapters were I was averaging, I was getting threes basically. But yeah,
You're saying that rotation is
25%. It's a quarter, like 20 to 25%. The teacher told us.
it is
I have my next mock on the 23rd. If I this is what the optional one I was talking about, sir.
mm,
Yes, sir.
see
But
it is hardly
I will
15%.
do well on the mock. I will do well on the full mock. I there's no I have to do well on this one.
If you just try to understand that how what has more percentage, so fluid has 10 to 15% of weightage.
Yeah, I did well on
Similarly,
the
torque
fluids.
also have a 10 15% of weightage. This unit, similarly, if we talk about other unit, that is work, energy, and power, it has the most number of, you can say, weightage, more percentage of weightage. 18 to 23% of weightage is there for unit 3.
Oh,
Similarly,
there was
force
a
and
question, sir.
translation.
There was a question I had to ask you about the power actually. It came on my MCQ today. I just remembered.
Okay, tell me.
So, okay, I don't have the question because, like the teacher didn't won't release it. But basically, let's say there's like a hill, right? A hill.
Hmm.
Now, one side of the hill, okay, the left side of the hill, to reach the peak, the horizontal distance is shorter, but it's much more steeper. It's much more steeper. Okay, but yeah, so the right side of the hill has a longer horizontal distance, but it's less steeper. Now, let's say one person starts on the left side of the hill and one person starts on the right side of the hill, and they both make it on top of the peak at the same time. So now we have to compare the powers of A and B. And the height from the peak to the base is given as h.
This is given as h.
From so like if you construct a altitude from the peak of the from the top of the triangle to the bottom, that's given as h. Yes, sir.
So this is h, or this one is h. Altitude
The
is h,
sec-
or the
the altitude, the second one,
this one.
the one inside the triangle, sir. It's perpendicular to the base. Yes,
And
this.
what about other dimensions? Angles,
There's
nothing
no
is
need. There's,
given.
there's no need. Basically,
You have to
also
compare the power.
you have to compare the power, and they reach the top at the same time. And the horizontal distance for A is of course less than the horizontal distance for B compared to B.
The answer is going to be, it is same for both.
Oh my god.
Power consumption would be same for both.
So do we consider
Let's
the vertical component or the horizontal
let's
component?
let's prove it.
Okay. Oh my god, sir. I said that B would have more because he has to cover a longer distance in the same amount of time.
Power is not that. That is
Okay.
not power calculation. So if we define power, power is
Work over time.
rate of doing work. Remember it this way only. It is rate of doing work. Like you have to feel the definition of power. How fast you can do a given work. Just understand. Suppose there are two persons. Both persons has to lift 10 blocks of brick from one point to another. They are going to do the same job, identical job. But the first one takes 10 minutes to do that, whereas the second one takes 12 minutes to do that. So the same amount of work done in a lesser time will give us same will give us more power output. Like it requires more power. Just take it a different example. Suppose you're using a heater in a room and your heater is working at around, I assume, 30 degrees, or you can assume at 95, 96 Fahrenheit in room, and suddenly you increase the temperature to, let's say, 100 Fahrenheit. Now, at what in which case it is going to take more power, and the job of the heater is to do the room temperature at the given level in same time. So the power consumption in that case where more work is going to be done will be more. But here, if you just assume power is work done upon time, what is work done in both the cases? I'm assuming the person one is
They did not
going.
tell us the work done.
Yeah, I'm telling you, but the altitude is h. So what is the work done in going from point A to point B? Let us try to find it out. So to find this thing out, we have to assume that the mass of the person is m. So during its time of journey, there will be mg acting in downward direction, whereas normal acting in this direction. If we have to understand that about what force
Oh, it's
this
mg
person is
cosine.
doing work,
Mg cosine
about
theta.
against what force it is going to do work if you try to find out that. So work is nothing but force times displacement,
Oh, it's perpendicular to the displacement. Oh,
and that displacement should be perpendicular one,
oh, so
which
it's a
is
normal
h.
force.
So work done is actually being done against mgh, like
Wait,
gravity. If we are going up a hill, we are working against what force? We're working against our weight,
yeah,
and weight is a force which acts perpendicular to the surface. So if we take this component of displacement, then work is going to be zero because there is no force acting in this direction. Although we can say that there is a component of normal, but when we walk up a hill, we actually move our foot by putting it to the next point. We are not dragging it. We are keep on like walking. We are keep on moving by
yes, sir.
lifting our feet. So normal doesn't play any role, but that work done against gravity does a huge role. So for the person A as well as for person C, work
Oh,
done is
it's the
going to be
same.
same. And also it is given that they reach at this point at same time. So if they reach at same time, power for A is going to be mgh over t. Let me assume that it takes t time. And power for B is also equals to mgh over t because time is same.
Yeah.
So power for
Wait,
both.
sir, but I have a question. If work is force times displacement,
Hmm,
and in this case, our displacement is from line segment A to B, from point A to B, right? Then
hmm.
shouldn't the force be perpendicular to that line segment?
Now understand.
I don't understand this part, sir. The
Yeah,
problem.
yeah, yeah. I got it. You made a valid point. What is work done? Work done is F dot S. Fs cos theta. Force is mg, displacement is h. Angle between these two things is 180. So mgh, that too in negative. So here work done is coming out to be negative because work is done against gravity. That's why it is negative. Whereas if the same thing repeats in opposite direction, now work done is going to be positive because
Gravity is doing the work.
displacement takes place in the direction of gravity, or gravity is actually doing the work. So it doesn't make it doesn't have any issue here unless until there is some other force. The answer due to gravity will remain same. However, for
Wait,
both the case will
so
remain
I
same.
don't understand it though, because I don't understand why work done needs to be mgh. I thought work done would be like mg times like the length of line segment AB, because that's the displacement, no? Like it will be like it will be mg cosine theta times the length of A and B.
Now let's talk about it more then. So work is a scalar quantity, right? Whereas if you look at force and displacement, they both are vector quantities. So whenever we are dealing with vector quantities, the direction matters. Like for example, this is an object and we apply force on this object in this direction. What are the possible scenarios in which the particle's displacement is in opposite direction to that of force? Tell me,
Sir,
what are the possible scenarios that the direction in which force is acting, particle is moving opposite to that direction? What are the possible scenarios?
so we have
You deal
friction
with this
doing.
thing daily.
What are the possible scenarios?
Yeah, you deal with this thing daily, every day.
The friction, sir?
Yeah, the friction. But how? In what case?
The friction is
Tell me
doing
that.
work against us.
And when it happens,
When you move an object.
that is not a practical application. So simply imagine that you are sitting in a car and the car is going to be slow down. So what we are doing, if we just look at from the car's point perspective, it is going in the forward direction. Displacement is going on in the forward direction. But when we apply brake, what we are doing it? We are applying force in the opposite direction. So will, or you can say, isn't that force does some work here? And what is work done by that force? It is going to be negative because
Wait, isn't it
force.
zero?
Why would it be zero?
Because the
Isn't
force is
it?
not because the
Isn't
force is not
isn't it
perpendicular.
moving?
Oh sir, I'm so sorry. Oh, I
You
messed
are
it up.
confusing between two things:
Oh,
force
it's,
and
it's
torque.
parallel. It's parallel. It's supposed to be force is parallel to the displacement. Sorry, sorry. I was no, no, all this. Okay, okay. Sorry, sir. What I was
You are
originally
getting
thinking. Yeah,
confused with torque.
yeah, yeah. I was saying torque is the force times
Perpendicular,
force. Yeah.
perpendicular.
Oh my God. Oh, okay, okay, okay. Oh, I see now. I
So
was thinking. Wait, wait. Can you go back? Okay, okay, okay. So then,
that's why power is zero,
so then
or you
the
can say same.
work done here must be parallel to our displacement, right, sir?
Yeah,
Okay, then so in this case, when we are going up, gravity is doing work against us, right? A component of it, mg sine theta, right, sir?
right.
So if so, then how do we calculate the work that we are doing when we're going up? Why is it mgh then? Because the total component of gravity is facing down, and we are going is parallel to the we're going parallel to the height, right, sir?
Yeah, now it makes sense to you.
Technically, right?
Always you just have to observe that how object is moving. If object is moving perpendicular to the direction of force, if it is moving perpendicular to the direction of force, then work done by that force is zero because
Oh.
cos 90 is zero. If it is parallel or anti-parallel, then work done is going to be positive or negative. That is what you have to understand.
Okay, because I initially thought that we are not completely parallel to the height to the altitude h, so it wouldn't work. Okay,
Yeah, that is what you have to think here. That is how you have to think here. That is also important.
so it's not the slope steepness that matters; it's the height that I have to cover that
It's the
matters in this.
vertical height as well as it's the time to
The
calculate
time, of
power.
course, yes. But the work here is the same. That sorry, the work being done here is the same, and so is the time. Okay.
Yeah, so if both the quantity are same, the power consumption will be same. Now, other scenarios in which case power
Oh.
consumption is different for different force, different
But sir,
case.
sir, I have a question. If power
Yeah,
like is a watt, right?
yeah,
Like
power is what?
1 second. I want to ask you something. It was so like, but is the watt the same thing in electricity? Like the
Yeah, it
watt?
is the same thing. Yes.
Really?
Yeah, obviously, but we are doing it for the different thing. Here we are dealing with the physical objects. There we are going to deal with elementary particles, atomic particles, that is electron, proton. We are going to do the same thing. We are going to calculate, we are going to understand force, we are going to calculate work done, we are going to calculate power, and that power is again coming out to be work
No,
done
so
per unit time.
okay. Oh, so okay. If okay, power is if power is force times distance over time, then does that mean like the volt would technically be the force because it's the pushing pressure of the electrons because the movement of electrons is electricity, right?
And this is what we call EMF, electromotive force. I don't understand this thing. Like, this is the rarest thing happening to me in this session. What you have learned in physics so far? Try to tell me from the class one, like what you know about physics. Tell me in detail. What you have learned, how many topics you have discussed, you have given test. Tell me about it.
Sir, I've learned the force, the kinematics, force,
When
energy.
did you actually learn physics? In which grade you actually started
Like when did
learning
I actually
physics?
learn it? This grade, sir. I'm completely new to physics.
You are learning it like for the very first time as a
Like of
subject.
course in primary school, we learned all of the like common sense, but like we never learned like we never learned it formally. It was more like a like developing like an intuition for it. Like it was never formally like told. Even in science class, like my main science class in middle school, sir, was
How many years did you have science?
all I think all of my years, sir. Like in
From
high school,
first
sir,
to
from
no, no, no.
first
From first to eighth, you had science, and after eighth,
after eighth, I did biology, and then in 10th grade, I did So in eighth grade, I also did biology. In seventh grade, I also
okay,
did biology, and ninth grade, I did biology, and then 10th grade, I took chemistry honors,
okay,
and then
and now you
physics.
have physics.
Yes,
And
yes,
next year you are planning to have
either physics or biology depends.
like you are so much interested in biology. Why? Any specific reason?
No, no, I mean, no, no, because sir, like in middle school, right? They basically only taught us biology. Like that was the main topic. Like it was mainly like ecology technically, but they taught us like biology, and then I liked it in ninth grade. I found it interesting. I found it intuitive, and then chemistry I learned a lot. In chemistry, I actually also liked chemistry a lot. It was very fun as well.
And what about physics?
Physics, physics is it's subjective, like not everybody finds it nice. But I don't know. I'll still take physics. Maybe I don't want to
See,
judge. I don't want to judge physics
based
because
upon previous sessions and your ideas related to all the subjects, I feels like you should go for biotechnological engineering.
biotechnological.
Yeah,
Yeah, maybe, sir. But no, the reason I was asking about the what, right, sir, was because in chemistry we made like a galvanics and an electrolytic cell, right? And they said
yeah, we do.
that
We do
that
that.
so
In
there's a
physics also
flow
you are
of
going to do it,
electrons.
but
Yeah,
not you're
yeah,
going to make you're not going to make it.
yeah. So then no, so then the thought occurred to me like, oh, is the what like related to that? That's why. Oh, and then now I understand it because like the electrons like repel each other, right? So then there's a lot of pressure. It's like the same thing, like in fluids when you have pressure. So it's like
Mm,
volts is like
yeah,
the
the
pressure
term we
technically.
use is different. We don't use pressure term. But yeah, your ideas and everything that you relate, how you relate things is quite amazing. You should choose for something revolutionary. Revolutionary as in, if you look at the future, think about it. The biotechnology will play a lead role more than IT.
Oh, wait, so that means like amperage, right? If basically the pressure is volt, right, then the amperage would be like volumetric flow rate, right? Like
Kind of.
like the rate of flow, something like that.
Yeah, but for electrons. And will depend
Oh,
upon the property of the conductor. So, lot of similarities. See, 11th is something which is like this AP Physics 1 is something which in which you can actually feel things, you can see things. But in AP Physics 2, it is quite difficult for few students because they don't realize that what exactly happening here. Like what is moving, how it is moving. It is quite difficult to understand for few students because you can't see those things. But you relate it so well.
yeah, but I'm not taking AP Physics 2 next year, sir. I'm just going to take C.
Yeah, you told
Yeah,
me.
yeah, yeah. Because school doesn't offer Physics 2, and it's not like a prerequisite. And like it like already like it comes intuitively because in chemistry they basically teach you it, the electron repulsion and the intermolecular forces and all of that. You
Yes,
do, yeah. But I do not. But like I was thinking about the watt thing, and I was like, oh, okay, that's where the wattage comes from.
and in that subject, in that topic, we actually try to understand that how electricity bill is calculated.
Yeah, but I think I'm just going to do computer engineering, sir.
Let's see. It depends upon you.
It depends on which. I want money, sir. I know.
That's why I'm saying biotechnological engineering.
Yeah, perhaps, sir. Perhaps.
See, your dad will have a lot of connections, and it will easy, like it will going to be super easy for you to build an empire. But in
Empire.
IT, it is going to be a little difficult.
Yeah, I don't like the software side. I like the hardware side of
Hardware
it.
side has don't that much future. Matlab, I won't say that you will become the leading industry. Yeah, if you talk about Nvidia, that is a different story. But again, you have to deal
But
with
like they're
software.
so high in demand now, sir. Like the hardware engineers, like all of those people. Like software engineer, no, no, not so much. But the hardware engineers, they'll be very high in demand now because they're everybody is going to focus on how to make stuff like AI or GPUs and all of that more energy efficient because that's the only thing that's a limiting factor. Like the
Yeah, you're thinking right.
human brain can only needs like 25 watts worth of like power to function. But in order for the AI to do the same thing as the human brain, it needs like a city's worth of electricity. It's so inefficient.
And you got this information from your dad, right?
No, no, no. My dad does not do AI, sir. I don't think you are.
Yeah, he doesn't do AI, but
No, I
anyway,
know.
we
I
do
just
have a
read
lot.
about. I just read about it, sir. It was about, and also not to mention, there's so much. Like if you look at the data centers, right? There's so much water that gets wasted.
Yeah, yeah,
Because they
yeah.
constantly
Correct,
dump
correct,
fresh
correct,
water. Yeah,
correct.
and if you look in the small US cities, a lot of people suffer because of that. A lot of people, because of the all the treatment that happens there, the whole water system gets like contaminated.
Yeah, your way of thinking is quite amazing.
Thank you,
And
sir.
if you keep that thing in mind and be curious regarding to it, you will be definitely going to have something great in your life.
Thank you, sir.
Although that biotechnological engineering is also going to play its key role because
Yeah, yeah,
that contamination will lead to some sort of creation of new virus, and that virus will be created by somehow us only. So we have
yeah,
to create that, you can say vaccination and all as well. So they will play their role as well because in future it is going to like increase like hell a lot. We
yeah.
can't
But
even
it's a
imagine.
very prospective field as well. It's a very new field, which is good as well.
Yeah, it's very new field. We don't
Neuroscience
find
and
much
all of that.
findings. But
Yeah,
yeah, engineering with biotechnology is something else. It can cure anything. We cannot even imagine that what kind of effect it can have.
yeah.
All right
Well,
then.
yeah. I don't know, but I'll check.
Yeah, sure.
Thank you, sir.
But the way you think well is also very well. So
Thank you, sir.
stick
Thank
to
you.
it.
Thank you, sir.
All right then. Let's keep it here
Thank you, sir.
only. See you in the
Bye,
next
sir.
class.
Thank you. Bye.
Bye.